Hello, welcome back to IT Security Labs, and today we are going to gain persistence in our game of Active Directory lab. If you're brand new to this series, we are learning red team and pen testing skills and also defense skills by going through the game of Active Directory lab, which is free and open source. You can actually set it up yourself. In the previous videos, we were able to compromise our first host. In this case, is the SQL server. This SQL server is now communicating into our command and control framework Adaptix C2, and we have a beacon as a local user on this machine. Right now, our main goal is to proceed on this queue chain. Once an attacker gains access to an initial target, before they do a lot of things, they'll go to the queue chain and potentially want to gain persistence. So persistence gives us access or action or any change that we can make to the system that may, amongst other things, result in code execution when we lose access. Because we worked so hard compromising this system, the last thing that we want to do is for them to restart their machine and then we lose our access. So right now, we're very happy that we have access. Our C2 is calling in, and as you can see here, I have it on a 3-second sleep timer. But how do we gain persistence, and why is it important for us? Well, first, if this machine restarts, some people power off their machines at the end of the day. We want to be able to come back in as an attacker. Right now, we are lucky that this has been running for a while. My C2 Adaptix C2 doesn't show you how long this has been, but it's running, so we can connect. Let's confirm that. I can just run maybe dir. This will run BOFs in the background. So right now, as you can see, I'm able to communicate with this machine. To gain persistence, we can just run any one of the other options out there, like scheduled tasks, startup folder. But the best way to do it when you're using a C2 is to use what we call beacon object files. A beacon object file, or a BOF, is a lightweight position-independent C program that can be executed directly in memory, so it will run in the same memory of the initial implant that we have on the compromised host. And the goal is to use this extension of functionality without writing a new tool to disk, which can get us caught, or even worse, resulting in us getting kicked out of the system before we even gain persistence. So we're going to use a BOF. It runs in memory, it's fast execution and low detection profile. Notice that is low, doesn't mean that you cannot be detected. At the same time, we can also easily customize them. So in our Adaptix C2, can we run BOFs? This is a relatively new C2, so I chose to run our persistence as a scheduled task. All right, so we're going to use this PersisTask-BOF. This was written by Nick Zero, a BOF that uses COM object to interact with a scheduled task to create a logon task. So this is great for persistence and should be more OPSEC safe than conventional methods that it doesn't use task scheduler. So I like that it's using COM object. So it's something new that I haven't done before. And in order for us to use this BOF, we need to understand how Adaptix C2 works with BOFs. So for example, we have an extension kit with Adaptix C2. In this extension kit, we can create a custom JSON file that can be adapted to pretty much any BOF that is out there. Instead of having a .cna file or any ways that other C2s like Silver has a way to execute BOFs, CoverStrike uses a CNA file. This Adaptix C2 needs you to customize these BOFs. We're using a JSON format. I spent some time, and in the last video I mentioned how you can use it. I'm going to be using SQL Server, but before I do that, I will go to here. I have a tools folder. Then I can make I can say BOFs, cd BOFs. With Adaptix C2, most of the persistence and BOFs stuff is found in the extension kit folder. So if you go to extension kit, if you want to know how it actually works, you notice that, okay, here are the BOFs. So this is what I did. I was like, okay, here are the BOFs that they have. You can find those BOFs in the extension kit under extender. If you open extender, you'll notice that, okay, here are some BOFs. Here's an AD BOF. This is the JSON file that they use to define the BOFs. Okay, so we tell it like, okay, I want you to be able to run any BOF that is out there. We specify that we want the .o, the object file, in the working directory. In this case, this directory structure has to be correct. Since mine are not going to be in the normal location, I'm just using my tools folder. It will still work as long as, this is very important, your JSON file is in the same location as your .o file. So how does that work? Here, I already went through the process of cloning, so I can say git clone. You can put this in the extension kit folder, but I like to keep my curly separate. Now in the persist-BOF, we need to understand how to compile it. It says simply browse to the directory of the BOF and use make. So cd persist-BOF and then ls make. Let me show you in Adaptix C2 documentation where I found this. Under data and BOFs, here they define how you can create this extension, and it will show you sample syntax here, as well as what you need to do and define the different values that are needed. The only thing that I'll mention here is if your BOF takes different parameters, you will need to be very careful with how it takes them. I use Perplexity or ChatGPT to help me figure it out very quickly. But here's an example. You need to tell it to execute the BOF and the format that it expects. For ours here, I first need to run make so that I can have the .o file that this needs. And as you can see, I now have my .o file. I don't need the CNA because this is not Cobalt Strike. So what I can do now is I can say I want a JSON file for this. So I'll just, in the same folder, make my .json file. If you're brand new to this, you might need to go and read the BOF that you're working with, and then also the documentation here to figure out how exactly to work with it. The easiest way for me was to go to an existing BOF here, the AD BOF, for example, and I just found the JSON file. I was like, okay, it needs a name and so forth. So I went to Perplexity or ChatGPT. I gave it this example. I said, hey, here's how Adaptix C2 framework defines a BOF. I want you to create a JSON file for my file, and then using that format and syntax, and also Perplexity or ChatGPT needs to know this information here on how it runs, and simply it will just go ahead and give you the file. We might have to do a couple tweaks there. But after you do that, you end up with a JSON file for the persist one that I have right now. I ended up with persist.json. First, the name was just automatically given. I like to give the name to be the same name as the repo, the public repo that's out there. A description is pretty much the same description that is out there. The type is going to be a command for a beacon agent. The command that you'll be using to run this BOF is this persist task, and then you give it the syntax. So for example, you can give it a description and a message just to tell people what it is, but you give it an example. To run this, you need to say persist task, add, then the task name, and then the path to whatever you want to execute, an executable, a DLL, or a script, whatever you want to run, you point it to this. And then for the arguments, what are we expecting? Here, it's expecting a string for add or remove. You might be like, oh, how does it know? Here in the documentation, it tells us like, hey, persist, add or remove, and then task name, another string for the command to run. That's where that came from. And then when we come back, we say, okay, we need 3 strings, the action, the task name that we're creating, and also the command to run. And in this case, use double if you are going to be defining a path. And in order for us to execute this BOF that I made on my system, we're going to run an exec command. This is what the Adaptix C2 is going to run. Execute BOF. Then this xdir is going to say the location of the JSON file. We are going to have a persist.architecture. So sometimes you have a 32 or 64-bit, it will pick based on the type of beacon that you have, .o. Then it will append the strings that are required. In this case, these three that are defined here as arguments. That's pretty much it. And then make sure that your JSON format is correct. And once you do that, you go to your extenders. So in Adaptix C2, you go to extender, then you open extender. And when you open extender, all you need to do, let me unload it and reload here. All you need to do is click anywhere here, right click, and say load new. You browse to the location of your JSON file that you created. In this case, it's in tools, PersisTask-BOF, and then here's a JSON file. Open. So most important, as long as your .o file is in the same location as a JSON file and everything is defined, is the correct JSON information, and also that the arguments are clearly defined, then this should work. All now we need to do is go and run this PersisTask-BOF. So here, I actually have some notes that explains everything. So this will be in my GitHub. Link is going to be in the description. Then upload it to Adaptix C2. I show you as well. Next, we are going to need our payload. What is this going to run? In this case, I want it to run an executable that will be executed every time the system restarts and the user logs in. So how do I do that? First, I will need to generate that executable. So I'll go to my listener in Adaptix C2. I say, okay, this listener, right click, create, and then here, no, I don't want to create. I want to right click, generate an agent. You can create any type here. This is a beacon for Windows, and the architecture is correct. It's an executable stuff here. I'll just say generate. This is going to be in my payloads folder. So this is going to be, let's do this, Kali, desktop, payloads. And I'm going to name this one. Since I want this to persist, I'm going to name this wintask.exe. Sure. This will be in my payloads folder. I'll save. Okay. Next, I need to upload that to my victim. So you choose a path. In my documentation here, you might notice that I put it in C loaders adapt.exe. Yeah, you can put it there if you want. I guess, yeah, let's do that. I can say cd, C loaders. We're going to upload using Adaptix C2 framework. This is a custom directory, so just know that Windows and AV might watch this more closely. You might want to put this somewhere like a native location. In this case, I'm putting it in C loaders. Then I can say help upload, because I have an upload command here. It says upload, so I can say upload such home, and then I want wintask.exe, and then come back here. Tab completion is not a thing here, so you know. Then paste. This is most likely going to trigger our Elastic, because it's a file that is no, like literally no evasion whatsoever. It's out of the box, so I'm expecting it to be chewed up by Elastic agent here. Then for the path, it's C. Sure. I wanted to put a full path to show you that that's how you put it according to the help here. Then I can say there. That's a BOF. And now wintask.exe is here, and here's the size. All right, that's pretty much it. Now that we have that out there, we need to, can I do a help? I think I should be able to ask it for help, and it will tell me. Yeah, so here's my help for the BOF that I put in there. Here's an example from the help. I like to just copy the example, paste, PersisTask, add my task, and then the path to where I want things to be. In this case, my payload is in this location, fixing it, of course. Remove the double. The task name, I'll name it win task, just so it's easy to see. Of course, you need to name your tasks so that they can blend in. Here we have double quotes. I'm not sure if I need to use them or not. I've used with and without. So let's see. Yeah, persist task, add task, win task. And let's see if it works. All right, it works. With double, it still works correctly. So now the BOF has successfully created a task. The problem is this is still generating a task. So the task will be seen in the Windows task folder. So let's go to here. I'll show you. So if I do an ls on the Windows tasks folder, I should be able to see. So now if I do a dir this directory, I see my win task. All right, so we have a task on the machine, and the task is telling it when the system reboots, we should be able to execute my win task. Notice that right now I'm in with my adapt.exe. When I restart this system, I should be able to come back in and be able to see now that I get a new callback that is now going to be with wintask.exe. But I don't think that this is as stealth as I would like it to be. Right away, you notice that we got an alert here, power detection alert. So let's check, why are we getting busted already? All right, so this is a malware detection alert. This was when we actually uploaded the binary in C loaders. That was just the binary being dropped. So we didn't do any evasion. That's why we're getting this alert here. I'm expecting another one when the rules engine runs for creating the task. But for now, dropping that binary, of course, got us caught. Now that our persistence is on, we can reboot this machine. So the easiest way for me is to simulate a real user, maybe by just going inside of the machine using RDP and restart it. So I'm signed into the server. I'm going to go here, power, restart, and continue. So when we do restart, it's restarting the system. I should get a second callback here. So right now, as you can see, the time is increasing. It was 4 seconds. Now it just keeps increasing. If it all goes well, we should get a new callback with a new process called win task here. Here, let me take a chance to say your binary might actually get detected and it will not execute even though your Elastic EDR might be in detection mode only. In the next video, I'm going to show us how we can use some of those loaders that I've made videos in the past, like Scarecrow, to see if we can package our Adaptix C2 payloads and still not trigger any detection alerts. So, for example, if I go to the alerts here, you will notice that we have a lot of detections. This was me earlier when I was playing around with it. It gets, your payloads will get caught. Like, for example, this was WinTask 2. It was getting caught with malware detection. It wasn't working. So we need to load that using a loader so that we can bypass some of these. This will happen after you have executed a few of these payloads in your environment. So just in case that happens, watch the next video so we can work on bypassing AV. So far, it has been 1 minute. Let's see. So it did successfully restart. It came back with wintask.exe here. So it shows us that our persistence is working. But however, if yours doesn't work the first time, the first thing that you need to check is whether or not your win task is actually working or not. You will notice that sometimes it will get caught and it will not even run, even though you just have detection working. If you're having issues executing the payload, watch the next video where we can try to use Scarecrow or some of these loaders with Adaptix C2 to see if we can bypass and still be able to execute our payloads. However, you notice that using the BOF worked because we don't have any alerts that mention that we created a task whatsoever. We do have alerts on just the execution, the beacon. And here is so we did get caught. That's interesting. The COF loader, the way that we executed it. That's very interesting. I'm very interested in knowing like why it generated this random file name here. was our task. We know the name of the file. And this was also from the recycle bin. And that's why we do these labs, so I can go and find things to investigate. Anyway, if you know why we ended up with this random name here after our persistence worked, let me know. Otherwise, this is my next task. Figure out why this is happening and why recycle bin is now involved. And also, it's seeing Process Explorer. That is interesting. Again, we just got detected. However, using the BOF to execute and load it did not cause us any, to create the task was not detected, which was our main goal. Otherwise, thank you for watching. I hope you learned something here. And if you need a guide, I'm going to paste this document on GitHub so you can also follow along if you prefer the text. Otherwise, thank you, and I hope to see you next time.